Welcome to question 8 of the 2014 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 8 we have a continuous random variable x with a probability density function given by the following hybrid function. The median of x is m, and for part A we're asked to determine the value of m. So not that it's necessary, but sometimes it's useful just to have a quick sketch of the graph when we're dealing with these sorts of problems. So this is the curve that is 1/5 e to the power of negative x on 5, and this coordinate here would be 0, 1/5, and we'd also have 0 elsewhere, so that would be an open dot and 0 out to that side. And because it's an exponential graph, we have an asymptote that occurs when y equals 0. And if m is the median, we can use that to set up this question. So there must be some value of m here, such that the area below it or above it is equal to a half. So the area here is 1/2 or 0.5. So therefore we know that if we were to integrate between 0 and m of the function 1/5 times e to the power of negative x over 5 with respect to x, that would equal 1/2. Therefore, if we calculate the antiderivative, we would have 1/5 e to the power of negative x on 5. We would divide by the coefficient of x, and dividing by negative 1/5 would be the same as multiplying by negative 5. So we'd simply get negative e to the power of negative x on 5, and that is going to be between 0 and m, and we know that is equal to a half. So to evaluate that, we're going to start by substituting in the upper terminal. So we'd have negative e to the power of negative m divided by 5. And then we'd subtract away the lower terminal substituted in, which would be negative e to the power of negative 0 over 5. And that would still equal 1/2. So therefore, in our next line, we would have negative e to the power of negative m divided by 5. And two negatives will give this being positive, and then we have e to the power of 0, and we know anything to the power of 0 is simply 1, and that's still going to equal 1/2. So therefore we would find that e to the power of negative m on 5 would equal positive 1/2. So if we rearrange that equation, and then we can express this in an equivalent log form, so that will give us negative m divided by 5 is equal to log e of 1/2, and then multiplying both sides by negative 5 we would get m by itself, so m is going to equal negative 5 times log e of a half. So that is the answer to part A of this question. Now just before we go on, you could have expressed this as m is equal to, and the negative could be used as a power on the half, and it would be 5 log e of a half to the power of negative 1 is simply 2. And you could also have put the 5 up as the power and got m is equal to log e of 32. So any of those answers would have been satisfactory. From the examiner's report we can see that 43% of students got this question correct. And while most students knew to set up a definite integral involving m and equating it to a half, the errors occurred with mishandling of negative signs involved in the antiderivative, or problems with algebraic skills when solving. Some students confuse the median with the mean, or the total law of probability. For part B, we're told the value of m is a number greater than 1, and you'll see why that's important in a moment. And using that information and the rest of the information in the question, we're asked to find the probability that x is less than 1, given that x is less than or equal to m. So if x is less than 1, if we do that in purple, we knew that m was greater than 1, so 1 must be some number less than m, and we're now interested in the area between 0 and 1, which is now shaded in purple. And we're going to find the probability that x is less than 1, given that x is less than or equal to m, which was already the area shaded in green in our diagram. So even though the diagram wasn't particularly necessary for part A, it's now quite useful for part B. So therefore, we know that the probability that x is less than 1, given x is less than or equal to m, And now that conditional probability can be calculated by finding the probability of their intersection, which from the diagram is simply the purple region, which is the probability that x is less than 1, divided by the condition, which is the probability that x is less than or equal to m. So this is going to equal, and now the probability that x is less than 1 is simply the integral between 0 and 1 of the function which had a rule 1/5 e to the power of negative x on 5 dx. And then we divide that by the probability that x is less than or equal to m. But we know that m is the median, so therefore the probability that x is less than or equal to m is simply a half. So our next step in this calculation is to find the area associated with that purple region, and we had the antiderivative before was simply negative e to the power of negative x on 5. And we're still going to go between 0 and 1, so that's going to give an area under the curve. And then we did have to divide that by a half, which is the same as multiplying this by 2. So this is simply equal to 2 times, and first of all we're going to substitute in the upper terminal into the antiderivative, which will give negative e to the power of negative 1 on 5. And then we subtract away the antiderivative with 0 substituted in, so we're going to subtract away negative e to the power of negative 0 over 5. So our answer for this question is going to be 2 times, and then the subtract negative e to the power of 0 is just plus 1, so we're going to have 1 subtract e to the power of negative a fifth. So that is the answer to part B of this question. From the examiner's report, we can see that 24% of students got that question correct, and 48% of students got 0 marks for the question. And overall, the question was not handled well in this exam, and the most common error was assuming that the value of m obtained in part A was equivalent to the probability that x is less than or equal to m. But we knew that m was the median, so the probability that x is less than m had to be a half.